Hello, everybody. How are you? Good? Yeah? I saw lots of people went to the pub, so I'm actually surprised by this turnout. So thank you for joining me for the first talk of the day on Stranger Danger, how to proactively identify misconfiguration to minimize system failure. It's a long title. An alternative title would be, what the fuck are misconfigurations? Who here has heard of misconfigurations? Hands up. Do you know what they are? Okay, some hands, good. Going to go into more detail. Now, before I start with my slides, before I do that, a little bit more about myself. So I work since early 2022 as open source developer advocate at Aqua Security. So just with our open source tooling. I also have a YouTube channel where I talk about cloud native tools, where I show end-to-end tutorials with different tools. I started a YouTube channel when I got started in the cloud native space about 2.5 years ago. And I have a weekly DevOps newsletter where I share free online learning resources from amazing people across the space, so that might be interesting. That's the link there. I used to be a CNCF ambassador. I'm not a CNCF ambassador anymore, though. However, I'm still an Open UK ambassador. If you don't know what Open UK is, do check it out. They support open source, open hardware, and open data across the UK, and host a lot of conversation around the politics of open source. Now, story time a little bit. So I have been working as developer advocate for several years now, first in the blockchain space, and then I transitioned into the cloud native space. And in 2021, I thought, I'm going to try myself as site reliability engineer. So I joined this smaller cloud native startup in the UK as site reliability engineer, and basically we were hosting Kubernetes clusters. You could spin up Kubernetes clusters, and they were run in larger Kubernetes clusters. So it was kind of like Kubernetes cluster and Kubernetes cluster. And I was part of their SRE team, making sure that the observability tooling is all set up and reporting correctly when systems didn't go as they were or didn't run as they were supposed to. And that happened quite a lot. So we really had to make sure everything is working correctly so we are not paged in the middle of the night for nothing, right? Now, we were testing the systems thoroughly. However, when I got started as developer advocate at Aqua Security, and I have to say I'm not a security professional, I'm just getting started still with all of the security tooling, and I realized that we are not testing our security tooling in the same way that we're testing our observability tooling. We're just kind of installing our observability tooling, Prometheus, Grafana, whatever you're using, our observability tooling, and we test it thoroughly. However, with our security tooling, we don't really test it. We're just setting it up and then hope it's going to run as we expect it to run. It's the configuration are working as they are expected to work, and that's it. So this talk is really about what are misconfiguration, how can we identify misconfiguration more proactively, and also test our security tooling to identify misconfiguration and other security issues correctly. So if you don't know what misconfigurations are, basically, whenever you're setting up a new platform, a new tool, you're configuring it in some way. And that could be, for example, when you log into Twitter and you're configuring how your birthday should be displayed on Twitter. That's a configuration. Now, I'm talking here specifically about cloud configurations. And cloud configurations is anything that you set up of how it's supposed to run, what it's supposed to run, where it's supposed to run, and so on. So in the case of cloud native tools, this could be like your Helm charts, your Kubernetes YAML manifest, Kustomize, Terraform, any other infrastructure as code tool that you're using. But it could also be the different cloud platforms, SaaS platforms that you're using to set up your different tooling. Now, here is a basic Kubernetes deployment, and in that you specify, for example, the number of instances of your application that's supposed to run. All of these are configurations, and configurations are really everywhere. But also misconfigurations are everywhere. Now, this data is taken from a 2020 run table that a coworker of mine found on GitHub that details lots of different misconfigurations and the kind of impact that those misconfigurations had. So, for example, the number of data that those misconfigurations exposed. And here, just to provide an example, there's this row over here, no password protection or any kind of security protection for the database. And it exposed 440 million records, just as an example. Now, in this database, you will find lots of different, like, for example, lots of S3 buckets that are misconfigured and other misconfigurations that ultimately were not really difficult misconfigurations or like misconfigurations that you might think first looking at it people surely would know how to set it up, but it's actually quite common to set things up in the wrong way because these platforms that we're using are very complex. So clicking the wrong buttons or not configuring things in our thousands of YAML files is one way to get it wrong. Now, across our software supply chain, we're using different tools, like anything that's basically touching our application, that's going into our application in any way, is part of our software supply chain. And anything that's across our software supply chain can be misconfigured. Now, misconfigurations, if you get started with new tools, you might think, oh, they're just sweet little things. They're fine. I will fix it later on. It's OK. They can live there. They can stay there. But it's actually something that can explode in our face any second and make things go terrible wrong for us. There are like other data, so for example, people getting started with Kubernetes clusters, and they're accidentally making them also publicly accessible. That's something we don't want to have. And one thing that can help us to identify misconfigurations more proactively are security scanners. Who here is using security scanners on a regular basis? Hands up. OK, a few people. Awesome. Who here has never heard of security scanners? Cool. OK, also a few people. OK, let me give you a brief overview of what security scanners do, what they help us to achieve. Now, I hope you can kind of see this graphic. If not, I'm going to describe it. Security scanners are these tools that we can install over in different environments. We can use them from online platforms. There are multiple different platforms that provide security scanners. There are also open source and proprietary tools that allows us to do security scanning. Now, security scanners at a very high level, they take in different information. For example, they take in a vulnerability database of the different vulnerabilities that are found in different packages, different libraries. They take in frameworks and best practices. In the case of Kubernetes, you might have heard of NSA, CIS, compliance. Now, these are entities that define what are best practices and how you should configure your resources. Now, security scanners also take in common misconfiguration. So for example, at Aqua Security, the enterprise team, they kind of see what are some common misconfigurations that people have in their different resources. So a security scanner takes all of that information, and then it takes the resource that you want to scan, the configuration file that you want to scan, and it performs checks. And these checks could, for example, be that best practice is that you set the name of your configuration file. Now, the scanner will then see, is there a name defined? If it's a yes, then the configuration passes. It's not a misconfiguration. If it's a no, then the check fails, and it's a misconfiguration. Now, these reports, these scans, ultimately are put together into a scan report. And depending on the tool they're using, they will be different kinds of scan reports. Now, just a quick overview of the tools that we have at Aqua. And I'm just using here Trivy as an example. Who has heard of Trivy? Hands up. Who knows Trivy? Oh, some people. Awesome. Thank you. Trivy is an all-in-one cloud-native security scanner. It's completely open source. You don't sign up. You don't send us any data. You can use it as much or as little as you would like. Lots of different companies are actually integrating their own security scanning with Trivy. And then we have Tracy, which is a runtime security and forensic tool using eBPF. Now, a little bit more about Trivy. As an example of a security scanner, it has 4 different types of scanners: a vulnerability scanner, a misconfiguration scanner, secret scanner, and license scanner. And these can scan different scan targets. For example, you can give it, in the case of misconfiguration, your Terraform configuration, your Kubernetes YAML manifest, and all kinds of other resources where you want to check, is it configured correctly? And you usually do that before you deploy that file into your different environments. Misconfiguration scanners, just Trivy as an example, is really done by the developer usually before the resource is deployed. It's not a defensive tool. It's not something that's supposed to, on the go, find issues as they happen inside of your environments. Now, just highlighting, there are different types of security scanners. Trivy is just one. Depending on what you want to scan, you can also use a scanner that focuses on vulnerability scanning or on scanning your different cloud environments as well. Now, let's focus a little bit more of the process on how you would usually use security scanning in that case. Usually, you would define a resource, or you would change an existing resource. And then you would run the security scan. So for example, I set up a YAML manifest for my Kubernetes environment where I specify how my container is supposed to run. Then I scan that resource. And then I shown with the security scan. And if there's anything wrong in the scan, I can then go back to the file and fix things. And that's really a quite reactive approach of identifying issues and then fixing them. It's not a proactive approach. It's not, I'm relying on the security scanner to then actually tell me which misconfigurations are my resources, and then it's on me to find them. And I'm hoping that the security scanner works as expected in that case. Now, the actual process might be a little bit more complex of the different steps that a security scanner would go, or like that you would go through for your security scanning until you fix the resource. So if a configuration change takes place to one of your deployment resources, and it's deployed inside of your cluster, for example, or in a different environment, then if you have a security scanner that's living inside of that running environment, inside of your staging environment, inside of your production environment, it will then trigger a security scan if the resource changes. So it will monitor your resources, a resource changes, and then it will perform the security scan. Then the metrics, the outcome of the security scan, can be forwarded to your observability tooling. Last year, I think also at the online version of WTF SRE, I talked about how you can integrate security scanning, security tooling into your observability stack. So you can forward security metrics, for example, to your observability stack as well. And then you can also set up alerts. For example, if there's a new critical issue identified in your configurations, then you want to be notified about it. Then somebody hopefully receives the notification, looks at the scan, and identifies where this misconfiguration comes from and is able to fix that. So there's quite a long process going on here and several different steps that can actually go wrong. However, with security tooling, when we set it up, we usually rely on everything working as expected. We install Trivy, for example, inside of our cluster, inside of our environment, just as an example for a security scanner. And we usually don't test the configuration as thoroughly and as in a regular manner as we would with our observability tooling. And that's similar to, and that's how I at least explained it to somebody the other day. It's similar to if you're using a car that has never been tested before. It's a new car model, and you just hope that everything, the brakes, I don't know much about cars, everything is working as expected, and that in case you have to hit the brakes, they are actually going to work at whatever speed you're going. So how can we ensure that our processes are actually working as expected? How can we verify that the configuration of our security scanning, just as an example, for our other security tooling is set up correctly and working as expected? One option is chaos engineering. Who here has done chaos engineering before? Ah, awesome. Also a few hands. So just a quick overview. I really want everybody to take the most out of this talk. Chaos engineering is a discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. I have to read that. So it's basically, in chaos engineering, what you want to do is you want to purposefully make things go down, make things go offline, and then see if components of your application go offline. What happens in your system? Does it still work as expected? Now, it got started by Netflix with a tool called Chaos Monkey in 2010. They thought, okay, we're using AWS for the first time. What happens if parts of our environments just go down? Can people still access our streaming services? And then they open sourced it in 2012, I believe. And Chaos Monkey, as well as KubeMonkey, is really there to turn things off in your different environments. It's very straightforward, turn things on and off. Now, Litmus, Chaos, and Chaos Mesh are two other open source tools that are part of the CNCF that you could be using to run Chaos experiments, to say, okay, if parts of our application go offline, don't run as expected, what would actually happen? So chaos engineering is very much focused on the reliability, testing the reliability and the resilience to failure of your different components. Now, there's a new term called security chaos engineering that came out a few years ago. Who here has heard of security chaos engineering specifically? One person. Oh, cool. Awesome. So I came across chaos engineering just a few months ago because I was wondering how can we actually verify that Trivy, for example, is installed correctly. It's also called security experimentation because people don't really like to mix chaos with security. It makes them freak out a little bit. Not a good idea. So security experimentation is a more proactive, more experimental way of expressing the same thing, similar thing. Now, it is defined as security control failures, or identifying security control failures through proactive experimentation to build confidence in the system's ability to defend against malicious conditions in production. So how do you know that your applications, your processes are not running any malicious processes, right? You want to verify that that's not the case. You want to verify that if that's the case, that what happens afterwards is as expected. If you run, for example, a more defensive tool, such as Tetragon or Tracey from Acro Security, then you want to verify as well that they would pick up of any processes that are happening that are not supposed to happen. So that's ultimately what security chaos engineering is for. This is taken from a report from 2020 by Aaron Reinhardt and Kelly Shortich. They also just published a book around the same topic. Now, a little bit more about security chaos engineering, what it's about. It's not really a new term, but it's not talked about a lot. Now, there was a project called Chaos Slinger that implemented security chaos engineering. It's now archived on GitHub. There are some, or at least that's what the GitHub repository says, there are some organizations that forked it and then built their own frameworks around it. Ultimately, security chaos engineering seeks to proactively and adaptive learning over reactive patching. So it's very much focused on what can we do more proactively instead of waiting for things to go wrong. And then when we're already in a state of like, oh my God, there's this new incident happening, this new vulnerability coming up, we have to fix it right now. And when you're already in that state of panic, you can't really focus on improving your systems. And that's what happens a lot with security scanning, is that we find a new critical vulnerability and we are just focused on let's patch that, let's fix it as quickly as possible before something worse happens. But we're not proactively testing our systems. Then it's also focused on building a learning culture around how organizations build, operate, instrument, and secure their systems. Something I realized when I got started at Acro Security is that within the security space, people are not sharing as much in a I guess, constructive, accessible way as they would do, for example, in the SRE space. So it's really about making it okay to identify parts, components of your stack that you don't understand as best as you could. And then it's around control testing. If you already know what's supposed to go wrong, you can build a hypothesis of what should happen if things go wrong. And then here are the 3 different points that you want to focus as well when you run a security chaos engineering experiment. The scope of your experiment should stay small as possible, because if you trigger a security issue and it's in an application that's nested within your stack, then the effect could be related to multiple different other components of your application, and you might not know how to improve it the best way. It's also around resource constraint. Clarify which are your variables that you want to modify and that you want to test, as well as your systems that you want to test and what way you want to test it. And then also host post-mortems after you run a security chaos engineering experiment, because ultimately only that will give you actionable items from the information that you gathered during those experiments. Now, let's talk a bit more about the practical implementation, because so far this has been very theoretical. Now, I was thinking of giving a live demo. I'm not going to do that today. So ultimately, when you have here this different process set up, right, that I already highlighted, you want to trigger on purpose a misconfiguration, for example, and see what happens. For example, if I say I want to misconfigure one of my components, I could do that, for example, by changing my container image to the latest tag. Now, if I change the container image to my latest tag, what will happen is that it will just pull whatever, if there's a latest image on the container registry, it will pull that, or it would just pull any, the latest container image that has been pushed to the registry. Now, I don't want that in my environments, or maybe I want to be notified whenever my container image changes. So how can I verify that? Maybe I've set up Trivy, but I've set it up to only notify me of critical issues. Now, in the case of Trivy, changing the container image to the latest tag is not a critical issue. So maybe I'm not aware of that because I've never triggered this change. So I could make the change on purpose to verify would Trivy report it And then would my observability tooling that's supposed to notify me actually pick up on that? Now you could invoke changes on your configurations really in all of your different components, different configuration files. The thing is that if you have lots and lots of different applications, you wouldn't want to go ahead and do it manually, those changes. Because that would easily make it very messy if you can't have, for example, automatic rollbacks of those misconfigurations. Now, what you could do is you could set up a Kubernetes operator. Who here knows what a Kubernetes operator is? Don't expect you to have Kubernetes knowledge necessarily to follow this talk, but basically, you want to have an application that runs automatically on a continuous basis and monitors your different resources. And if certain triggers happen, if Y happens, then it should perform X. That's what an operator does through control loops. So what you could do is you could set up, let's skip to the next slide. Yeah, you could set up tools such as Litmus Chaos and Chaos Mesh as well, and they have SDKs available, which you could extend those tools with into security chaos engineering. Now, I haven't done that myself yet, but it seems possible to modify the way that these tools operate. What I've done, I've developed my own operator to test how that would work out and to test it in combination with Trivy as well inside of my cluster. So this operator allows you to modify your Kubernetes deployments and make sure that if changes to your Kubernetes deployments happen, and if you have, for example, Trivy set up, then you can verify that Trivy picks up accurately of these issues. Now, I've built this as a proof of concept, and I'm still planning to expand it. It's nothing that's probably production ready right now. But yeah, that's what I've played around with. So you could install that to trigger automatically misconfigurations across your environments. I'm gonna skip back. And that's similar to if you test one new car model and you test basically the way that it would behave in a car crash. And that's similar process of that's why you really want to trigger misconfigurations in your environments. Skip ahead. So summarizing the different use cases that you could focus security chaos engineering on is to test your security scanners, for example, that they are configured as expected, that they will respond to different scenarios as expected, as well as your observability tooling, that's configured correctly to pick up on your security tooling. A lot of times, especially if you have separate teams, some of them focus on SRE, reliability, resilience of your services, and the other one focus more on the security aspect. It might be that those two components are very disconnected. So you could also test a combination of both. Now, here's some additional resources. Here's the book on security chaos engineering that has just been published literally last week. And then I found some other talks from 2018, 2017 on security chaos engineering that the same authors gave as well. And that's it. Thank you.